on the computer. So good afternoon, everyone. And Valerie, we are recording this for you because I know you can't be with us today. Now, I want everybody to write the number 743. So write the number down, 743. And the reason I had you guys write down that number is because we are going to round the number to the nearest 10. Now, what does that mean to round it to the nearest 10? We do rounding in order to make good estimations. So for instance, let's say that I had a product that I wanted to buy, like a pen, and it was 99 cents. Do you think I should round it up or down? Up or down? What do you think, Stella?
Up.
Up to what?
Up to 100.
Up to $1.
Yeah.
Right? Now, Jason B, I'm going to ask you the next question. If I have $3.05, should I round up or down and to what?
Round down. Up to 400.
Yeah, Jason, hold on a second. This is for Jason B. Jason B, are you going to round that up or down?
Down to $3.
Right. You're going to round down to $3. Now, Eleanor, if I have $738, this is a little bit tricky because it's not that close to 700. And maybe we want to round that to the nearest 10. What do you think you would do? And there's no wrong answer here. This is really just thinking about rounding. You would round up to what?
740.
Yes. Oh my gosh, Eleanor, you just rounded to the nearest 10. Everybody look. She rounded to the nearest 10, but she had to look at the 8. And the 8 told her to round up. Now, what if, and this is for you, Jason F., what if it had been $731? Then would you round up or round down?
Down.
Yes. And that was for Jason F. You're going to round down. Jason F, to what? Round down to what?
731. Rounded down to 700.
730.
7.
730. But if we round it down to 730, we are rounding to the nearest 10. So, but I have the hardest question. Nobody answer out loud. What if I have 735? It's the same distance to 740 as it is to 730. Should I round up to 740 or down to 730? Raise your hand. And then I want to hear, oh, actually, you know what? Do me a favor. Write down the number that you think it is. So you either write down 740 or 730. Remember, we're rounding to the nearest 10. So who wants to share what they wrote down? Stella, we're going to go with you first.
740.
Wow. Why did you choose to round up?
Because I'm thinking like 5 is usually close to 10. Because like I thought, because since 5 is in the middle, I think I would rather go up, because 4 to 1 more sounds like numbers to go down. So I rounded it up to 740.
You know, guys, it's a really interesting explanation. Jason B., what did you say?
Same thing.
And what about you, Eleanor?
The same.
And Jason F., what about you? Round up or down?
Down.
Down. So it's interesting. There's a lot of people who disagree about this, because 5 is as close to 0 as it is to 10. But guess what mathematicians have decided? If the number is 5, 6, 7, 8, or 9, we are going to round up. And if the number is 0, 1, 2, 3, or 4, what do you guys think?
Round it down.
Round down. So now let's look at the problem in front of us. I want you all to write down what we would round 743. Do we round up or down? Write down the number. Remember, we're rounding to the nearest 10, and we have to look at the 3, and the 3 tells us which way to round. Okay, don't say it out loud yet. On 3, we're all going to say it. On 3, 1, 2, 3, go. If you said to round down to 740, you were correct. Now, the next one, I want you to write down 987. And then, does anybody know what the 2 little squigglies mean?
What?
I want to know if you think you know what they mean. Jason B?
It means is close to.
Yes, is close to. Some people call it approximation. Some people call it estimate. But I like is close to. That's my favorite. Now, I want you to write 987 is close to, then write what you would round it to. Remember, we're rounding to the nearest 10, which means we have to look at the 7. The 7 will tell us what to do. Now, don't say it out loud yet. Are you ready? Are you ready?
Yes.
Jason F, make sure that nobody's talking on your end. It's really important. Okay, guys, on 3, 1, 2, 3, go. Did you say 990?
Yes.
All right. And you needed to round up because the 7 told you to round up. Now, the next one, 251 is close to, make the 2 little squigglies. If you don't make the 2 little squigglies, then it's not going to be very squiggly. Okay, remember, rounding to the nearest 10, analyzing the units digit. Are we rounding up or down? Are you ready? Say the number. 251 is close to.
250.
Did you round down?
Yes.
Now, the next one is the hardest one so far. The next one is the most difficult problem not in the world, but it's difficult. Now, I want you to write it down. 665 is close to. Write it down. Give me 1 second.
I'm done.
Wait, don't say it out loud yet. And I'm just trying to get number 29 ready for you guys. There we are, 29. There it is. There it is. Okay.
It's not actually too complicated because you told us that 5, 6, 7, 8, 9 you usually round up. So
Well, I have to tell you, Stella, you were the one that had the great instinct to know which way the 5 tells us to round. Your instinct was it rounds up. So everybody say it on 3. 1, 2, and don't yell it, just say it. 1, 2, 3, go.
670.
And if you said 670, you guys totally rock. Now, the next thing I'm going to do is I'm going to ask you to estimate 3,782 and 2,255. And I want you to tell me what we should write below it. So for instance, the number 3,782. What do you think we should round to? What do you think we should round it to? Raise your hand, because I would like you guys to round to the nearest 100. I want you to round to the nearest 100, not the nearest 10, the nearest 100. Okay, Jason B., what do you think? Okay, go ahead, Jason B.
3,800.
Wow. You rounded beautifully to the nearest 100. Now, Eleanor, can you round 2,255 to the nearest 100?
2,300.
Wow. Now, everybody write down 3,800 plus 2,300. And I want you to add those numbers, which is so much easier than adding the actual numbers, because now we have 2 zeros, which is so good. And it looks like Stella has her hand up, but I'm going to wait 1 more minute to make sure everybody's got that. All right. All right, everybody. On 3, we're going to say it, not yell it. 1, 2, 3, go.
6,100. 6,100.
6,100. Now, did you guys carry the 1 in the thousands column? Oh, nice job, Jason F. Beautiful job. Now, Jason F., just so you know, I had to mute you because your sister or somebody was really loud on the other end. If there's any way, Jason F., you can ask your sister not to make noise in the background of our lesson. I would really appreciate it. So if you can ask, I would be, and then I can unmute you, and then we can hear everything. Now, everyone, let's see what happens when we calculate these numbers exactly. So write down 3,782, 2,255, and let's calculate exact. Thank you, Jason F. All right, everybody do that. Going to give you guys one more minute. Hold on a second. Okay. All right. So I want to ask Jason F. I'm going to unmute you. And Jason, I want you to give me your answer. Go ahead.
60,037.
So you got 6,037. Did everybody else get the same number? Wow, Jason, awesome. So now everybody, I want you to look at our estimated number, which was 6,100, and our actual number. Who can tell me what is the difference? If we took our estimated number and we subtracted our actual number, how far off was our estimate? So I want everybody to think about this. And Stella, I want you to write it down just to check your work. Write it down just to check your work. Okay, the difference on 3, 1, 2, 3, go.
63.
Oh my God. Guys, we were only 63 away from the right answer. Now, guys, if you borrowed a 1 to make that 0 a 10, you borrowed from the 0 to make it a 9, then you borrowed from that 1 to make it a 0. That is another great way to make sure. So 63, we say, is the delta. And delta means difference. And we show it with a symbol of a triangle. So the triangle means difference. Now, the next one, guys, I think, let's see. I think it was Jason B who gave us 3,800 and Eleanor who gave us 2,300. Stella, could you round the number 8,149, please?
From the tens or the hundreds?
I think you should, let's round it to the nearest 100. Now, guys, you should all be doing this right now. You should all be looking at that number because this one is really tricky.
8,100.
Wow. Stella, that was amazing. Guys, do you know why that was so amazing? because 49 is almost in the middle of 8,100 and 8,200. But Stella remembers that we said if the next number is a 0, 1, 2, 3, or 4, we must round down. And if that number is a 5, 6, 7, 8, or 9, we round up. Now, Jason F., can you please round 888 to the nearest 100? Go, Jason.
888 rounded to the nearest 100 is 600.
You think it rounds to 600?
No.
Now, Jason, think about it. Jason, does the 8 tell us to round up or down? What is the
Round
8?
it down.
No. Jason, go back to our little, here, hold on a second. Go back to where we said that if, let's see if we can find it. There it is. Jason, are you looking at the screen? You know, that's one of the problems, Jason. You have to keep looking at the screen. If the number after the hundreds is a 0, 1, 2, 3, or 4, we round down. If it's a 5, 6, 7, 8, or 9, we round up. Now, Jason, when you look at 8, do you think 8 tells us to round up or down? Come on, we round up. And when you make 8 1 bigger, what does it become?
9.
So everybody say it. 900. Now, everybody right now do 8,100 minus 900. Everybody do 8,100 minus 900. And write down your answer. Uh-oh. Okay, here we go, guys. On 3, 1, 2, 3, go.
88,000.
7,000.
7,200. 300.
7,000.
300.
200. Is it 300 or is it 200?
200.
Well, let's do this, guys. 0 minus 0 is 0. 0 minus 0 is 0. 1 is too small for 9. So Stella, what do we do?
So we take a 10 from the 8 and turn the 1 into 11.
And 11 minus 9 is?
2.
And 7 minus 0 is?
7.
And so the answer is 7,200. Now, I want to see what happens when we do the actual calculation. So everybody write this down, 8,149 and 888, and I want you to subtract. Remember, subtraction is finding the delta. Delta means difference. And the symbol for difference is a triangle. Okay. Now, I want to ask everyone to write down the answer and then show me on the screen. I want everybody to show me their answer on the screen. I can't really see Eleanor's. Eleanor, I don't, a little higher maybe, Eleanor, maybe a little higher. Little higher, little higher, little higher, little higher. Oh, your fingers are on the answer. Ah, that's kind of small. Let's see, Stella, higher, higher, Stella, higher, higher, higher. Oh, wait, Stella, that's the estimate. That's the estimate. And 7261. So everybody, what I see is 9 minus 8 is 1. 4 minus 8, 4 is too small. So we make 4 a 14. Borrowing 1 from the 1 to make it a 0. But isn't 0 too small for 8? So we make it a 10. Borrowing from the 8 and make it a 7. Now, everybody on 3. 1, 2, 3, go.
61.
Very nice. If you said 7,261, you are awesome. And guys, do you want to see the easiest delta there is? What's the difference between 7,261 and 7,200? Raise your hand. Come on, you can see it. You can see it. On 3, the delta is 1, 2, 3. And the delta is 61. That is the difference. All right. Oh, we are going to have fun with this next one. Now, the next one, we are going to name each quadrilateral here. So for instance, for A, you have to look at A. I want you all to draw something that looks like A and put a little A in it. And then write down the word that you think represents the special quadrilateral. Quadrilaterals are polygons with 4 sides. And I just want to show you one thing. I'm going to draw for you a quadrilateral that is not very special. That quadrilateral right there is unfortunately just a quadrilateral. It is not special. There's nothing special about it. None of the sides are the same length. None of the sides are parallel. None of the sides form right angles. It's not very special at all. But who can tell me about A? On 3. 1, 2, 3, go.
Rectangle. Rectangle.
Yep. This is a rectangle, but guys, guess what?
What?
It's also called a parallelogram. Everybody say that. Parallelogram.
Parallelogram.
No, say it really fast. Parallelogram. It's a really fun word. Now, what it means is this, and I'm going to draw this a little bit larger. If you look at these 2 sides, they are parallel. Everybody show me with their hands parallel. Show me parallel. Eleanor, I don't see. Eleanor, parallel, like this. 2 hands, parallel. Eleanor, can you hold up your hands? like this, parallel, just like this. Put two hands parallel. There you go. Is this parallel?
Yes.
Is this parallel?
Yes.
Is that parallel?
No.
No. Now, I could also take two pencils. Can you guys make two pencils parallel?
I'm gonna take a pen and a pencil, which that's what I have.
Now, guys, what parallel means is that if you extend the lines forever, they will never cross. Are these parallel?
No.
No, because they intersect. These are parallel. You guys got it? All right. That and look, there aren't just one set of parallel sides. There's actually two sets, and that's why it's called a parallelogram. The reason this is called a rectangle is because all four angles are called right angles. Can you guys show me a right angle, please, with your hand and thumb? Show me a right angle. Some people like to do this. Show me a right angle with two hands. You could also do it with your elbow. Do it with your elbow, guys.
Nice
That's
hand.
the right angle. Oh, wait a minute. Why not look at this? Isn't this a right angle also? So if, oh, wait a minute, guys, is this a rectangle?
Yeah.
That's a rectangle. Is this eraser? Is that a rectangle?
No. Yes.
It's pretty close. Eleanor said no, because you see the little curvies on the end? And do you know why they're curvies? Because Mr. Kramer has used the eraser and it actually had pointy corners and it's no longer pointy. Jason B, that's a great example of a rectangle. Eleanor, that's a great example of a rectangle. Oh, Stella, very good example. How about you, Jason? Now guys, what about, oh, Jason, that's a great one. What about this? Do you think this calculator is a rectangle?
It looks a little like it, but on that side, it's kind of.
Yeah, I don't like it, guys. The reason is, you see the curve right here?
Yeah.
That's a curve, and then these vertices are also curved. And Jason B, you're showing me a tissue box, and tissue boxes have rectangles on all the faces, which are a lot of fun.
Not
No.
all. There's not this face and this face.
Oh, wait a minute. I disagree. I think, hello, I think this is a rectangle. It's a parallelogram with four right angles.
But it isn't long, like.
Ah,
Hi.
let's talk about this.
Well,
When you guys think of a rectangle, you think of that, right? Why isn't this a rectangle? Go ahead, Jason B.
because a rectangle has to have two parallel sides that are longer than the other two parallel sides.
Ah, interesting. That is not true. So Jason B, this is a square which has four right angles and it has two sets of parallel sides, and it is a parallelogram rectangle. So this is a parallelogram and a rectangle, but it's also called a
Square.
right. So there can be special parallelograms with many different names. So B, what would you say B is called?
Square.
Well, we know it's a square.
It's
We know it's a parallelogram. And it's also a,
rectangle.
now, guys, guess what? It also has one other name. And this G right here is what the square is also called.
Diamond, diamond, diamond.
Ah, not diamond. Everybody thinks that's called diamond because teachers tell that to children, but that is not a diamond. It has a very special name. All the sides are of equal length. And it's called a, anybody want to try to take a guess? Go ahead. Say again.
Rhombus.
That's it, guys. It's called a rhombus. Everybody write that down. Rhombus. And a rhombus just means that it has 4 equal sides. And now remember, all rhombuses are also parallelograms because they have 2 sets of parallel sides. Now, what about this guy? What about C? Raise your hand. Raise your hand. What do you think? Jason F.
Parallelogram.
Did you say parallelogram?
Yes.
I agree. Does anybody have another name for them or C? Go ahead, Jason B.
Rhombus.
It's also a rhombus. And Stella, what about D?
Also a rhombus.
And Eleanor, also a what?
Parallelogram.
Right, it's a rhombus and parallelogram. Now, what about E? Now, E is very special. It's different from everything we've done so far. It's different than anything we've done. I want you to look for parallel sides, see how many sets there are. All right. What do you guys think? On 3, 1, 2, 3, go.
0. No.
Oh, what about this side and this side? Aren't they parallel?
Yes. No.
Oh, watch this, guys. You ready? If I extend those lines, aren't they parallel?
Yeah.
Yes, they are. So these are parallel, but there's only one set. So it has a special name. Do you guys know the name?
What? Kind of forgot it. Trapezoid.
It's called a trapezoid. And a trapezoid has, Jason F, just I want you to pay attention, Jason F. Jason, with your eyes, Jason F, look me with the eyes, please. There you go. A trapezoid has one set of parallel sides. Now, does anybody see another trapezoid in this group? Don't say it out loud yet. And Jason F, if you look at the screen, you'll be able to tell. If you don't look at the screen, you won't. Eleanor?
X.
Which one, F or H?
H.
Yes, H is also trapezoid. And the reason is because this side and that side are parallel. The other sides are not, but guess what, guys? This is a special trapezoid. Would you like to hear about the special name? Look at these angles. What do we call those angles, guys?
Right angles.
So therefore, this is called a right trapezoid. It's called a right trapezoid. Now, there's one more, F. Who can write down the name of F? Write it down on your sheet, please, right now. And Jason, F, I don't think you're writing down what F is because you're playing with your pens and pencils. And I'd really like you to write down the quadrilateral that is F. Who's going to show me what they wrote down? Hold it up to the screen, please. Come on, Stella, Eleanor, Jason, hold up to the screen what you wrote down. And Jason F, just write it with one pencil, not a pen and a pencil, one pencil. And Eleanor, you got to hold it a little closer. Oh, nice, Eleanor. Let's see. Jason B. I don't really see the name. You didn't write. Oh, yes, you did. I see it. I see it. Jason F, if you hold it with two hands, I can see it. Right now, it's flapping all over the place. Stella, what about you? Stella, hold it up quickly. Hold it up to the screen.
Actually, I don't really know.
Well, what do you think it is? What do you think it is? Come on, we've had these written down. Jason F, what do you think?
Think it's square.
Come on, Stella, there are two sets of parallel sides. What's it called?
Quadra.
It's a parallelogram, everybody. It's a parallelogram, just like G, just like D, just like C, just like B, and just like A. But it's only a parallelogram. It's not a rectangle. It's not a rhombus. It's not a square. So these are really fun. Now, there's one shape I want to talk about that we haven't really talked about yet. We've talked a little bit about this, but not about this one specifically. All right, Jason S, I want you looking at this. Jason B, Stella, Eleanor, what do you think we call this guy?
Parallelogram.
No, it's only a parallelogram if it has two sets of parallel sides, and that side is not parallel to this side. Stella, what do you think?
Trapezoid.
Yes, but it's a special trapezoid. What do you notice, guys, about these two segments? What do you notice about them? Do they look to be equal in length?
Yes.
Then we call this an isosceles trapezoid. Can you guys say isosceles?
Isosceles.
Say isosceles. Yes, Jason B.
There is also an isosceles angle.
No, they're not called isosceles angles. It's called an isosceles trapezoid. And let me give you a picture of an isosceles triangle. Why don't you guys draw for me right now an isosceles triangle? Now, here, an isosceles trapezoid has at least 2 equal sides. So an isosceles triangle has also at least 2 equal sides. Oh, nice. Isosceles triangle, isosceles triangle, isosceles triangle. I'm kind of getting carried away, aren't I? With isosceles triangles. I love them so much because they're so pretty. 2 sides are the same. 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 Isosceles triangle. Now, oh,
Same.
now, guys, I have an idea. Are you ready for my idea?
Mhm.
We're going to take an isosceles triangle and we're going to create an isosceles trapezoid. Are you ready?
Easy.
Do you see how I just drew a line parallel to the bottom base? So here we have an isosceles trapezoid. And here we have an isosceles triangle, which is really cool. And guys, what if we kept drawing parallel lines? Do you see how we draw now many, many isosceles trapezoids,
Yes.
creating many, many isosceles triangles?
Yes.
And they're so much fun. They're so much fun. The other thing that we can do when we draw these is we can color in each one of them as a different color. Those are a little thick. And you know, Mr. Kramer is getting a little carried away with his isosceles trapezoids, because don't we love isosceles trapezoids? I do. I love them very much.
I get you a pattern,
Yeah.
but it's not a pattern anymore.
Yeah, I kind of made it not a great little pattern. And let's see, what should we color? And that guy, did I just make him orange?
Yeah. Well, yeah.
Orange, orange, you glad I didn't make a parallelogram? Now,
Funny.
I'm going to show you one of my favorite shapes in the whole wide world. And I don't know if you would like this shape, because not everybody has this as their favorite shape. All right, are you guys ready?
Yes.
All I'm going to do is I'm going to draw, make a cross first. Are you ready? And then watch me connect the dots. So these are called diagonals. The green segments are called diagonals. So this is, let me write it in black. These are called diagonals. And these are called diagonals. And who can tell me what figure A, B, C, D is? So A, B, C, D has a special name. And everybody should be looking at it. It's got two sets of equal sides. Does anybody have any idea what it's called? What does it look like? Jason, B?
A parallelogram or a rhombus?
Uh-oh, no. Rhombuses have 4 equal sides, and these two sides are different. Parallelograms have 2 sets of parallel lines, and this has no parallel lines at all. But that was a really good guess. Anybody else?
I thought you said what was close, no, what that looks like.
Oh, but I still do not think it looks like parallel lines, and it doesn't look like equal lines for all of them. Eleanor, what do you think?
Trapezoid.
Say it again.
Trapezoid.
No, because there are no parallel. Remember, trapezoids have to have one set of parallel lines. So that was a good guess, but we need something different. I'll give you a little hint. It's something that Mr. Kramer likes to do on the water. I always fly a kite. This is a mathematical figure called a kite. Now, kites are very special. Kites can be drawn in many, many different ways. Let's see if we can draw another one here. Oh, I think you guys are going to like this one. Now, this one is a crazy kite. You ready?
Yes. Well, yeah, basically. It's kind of like there's a triangle inside. I actually, that looks like kind of like a paper plane.
Now, that is called a convex kite because one of the diagonals is on the outside. This is called oh, I'm sorry, I made a mistake. This is a concave kite, whereas this one is convex kite. Convex means is that all diagonals are on the inside, and concave means at least one diagonal is on the outside. So I want you guys to have a lot of fun drawing these figures this week and practice, 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 because if you can draw them, we can build really cool stuff together. So kites, trapezoids, parallelograms, rhombuses, rectangles, squares. Wow. Valerie, we can't wait to see you next week. Everybody, I'll see you from the warmth of the Bahamas next week. I'm leaving Boston tomorrow, and because it's too cold for me, it's too cold. All right, guys, I'll see you soon. Bye.
Bye.